Dominguez, and I thank you for joining Vista Presents Isolite and an education on emergency transfer devices featuring Tom Deutsch. This morning, Tom is going to spend about 15 minutes clarifying the codes UL 1008 and UL 924. This knowledge will give you and your clients options when using emergency generators, inverters, and transfer devices. As always, I'm joined in the office by Francesca Dominguez and Jason Rodriguez, who will be monitoring content and chat communications. And please note that all microphones have been silenced as this session will be recorded and archived. And stay with us to the end of the presentation as we'll ask our $20 question and give you the opportunity to win an Amazon gift card. Thank you for taking the time, Tom. So tell us about UL 1008 and UL 924.
All right, I'm happy to do so. So again, my name's Tom Deutsch. I'm a sales support engineer over at Isolite. And today we're going to be talking about transfer devices. Real quick, there's many different ways you can reach code compliance in an emergency lighting system. The two we're going to be talking about today are generators and inverters, because that's where you're going to use these devices. Generators, obviously, they're not going to be running when you have general power. Your normal power is activated. You're going to need a switch to transfer switch to run a generator when you don't have normal power. Inverters are a little bit different. They work a little differently. When normal power is going to pass through the inverter, and when power is lost, they're going to draw from their batteries as opposed to the grid. There's some pros and cons to generators. They're reliable for an extended time. They do have a high capacity and no recharge time. Some cons, they require some additional hardware. They require fuel, they're large, loud, and they have long transfer times. About 10 seconds, whereas an inverter, you're talking more like milliseconds. So for inverters, some pros, they're designed for emergency lighting specifically, not just for general backup. There's nearly no transfer time, as I mentioned. They utilize your existing fixtures. It's a way of centralizing the battery. So as compared to like having a bunch of bug eyes everywhere, or what we call a batteries everywhere solution, we are now centralizing the battery into one location, one point of testing and maintenance. Some cons, if you could consider them, would be like you only have 90 minutes or 2 hours if you need. But that's not really a con because we're in the emergency lighting space. We're talking about emergency lighting. You're not going to use these as you would a generator. You're going to use these for your emergency lighting. So some of the commonalities are that they are, obviously one is more of a general power source, like I mentioned, whereas the inverter is specifically for emergency lighting. But what they have in common is that they're not illumination sources. They are power sources. And they also don't have intelligence built in. And that's where these emergency lighting transfer devices are going to come into play. So a little bit first about code. We're going to have a path of egress leading you out of the building. That is what our emergency lighting is aiming to do. And along this path, we are required to maintain 1 foot candle average and no less than 0.1 foot candle along any point on that path. Additionally, we must maintain a maximum of a 40-to-1 max to min ratio of our lighting. So for example, if we have 0.1 foot candle is our minimum at any point along our path of egress, we cannot have more than 4 foot candles at any point along our path because that would be greater than a 40-to-1 ratio. The reason we do this is you could create glare if you have a really bright spot. It might, maybe your eyes, they adjust to the bright spot and then the rest seems darker. So they make you spread the lighting out a little more evenly. There's also some additional performance requirements. The emergency lights must illuminate within 10 seconds of the emergency. That's something that an inverter is never going to approach. But with generators, sometimes you can have that issue. We've certainly seen issues where buildings had to completely change their plans for generators and switch to inverters because their generators weren't spooling up within 10 seconds. Emergency lights, they must also stay illuminated for 90 minutes. That's the minimum. You are allowed, however, to degrade down to 60% at the end of those 90 minutes. So these ELCDs, these emergency lighting control devices, what are they? Well, they enable general illumination lighting fixtures to act as emergency lighting fixtures when emergency is occurring. So they let your regular lights act like emergency lights. And there's two main types here. There's our ALCR, or our 924, and our BCELTS, or our 1008. For our ALCR, or our 924, these are a device used to set normally dimmed or normally off switched emergency lighting equipment to full power illumination levels in the event of a loss of normal supply by bypassing the dimming and switching controls, and to return the emergency lighting equipment to normal status when the device senses the normal supply has been restored. In other words, these devices are used to override the dimming and switching controls, and they require normally on power source. Our 1008 devices, they work a little bit differently. They're a device connected on the load side of a branch circuit over current protective device that transfers only emergency lighting loads from the normal supply to an emergency supply. So these devices, they change the power source that supplies power to the fixture, whereas the ALCRs are just a relay, and all that relay can do is open and shut. These are an actual transfer switch. They convert normally off sources into normally on sources. A quick note about these ALCRs is that I did mention earlier that inverters typically, they don't have the intelligence to know how to like override switches and stuff. However, we do have an inverter, our E3 Mini, which does actually have a couple of ALCRs built into it, up to 3 or 4 of them. So for each zone of lighting or for each room, each switch that you have, you basically have ALCR functionality built into them. So I want to dig in pretty heavily here to this ALCR one-line drawing. This is going to sort of give us an understanding of exactly how these devices work and where they're used. So to set the scene here, you have a room and you have 3 fixtures in the room. We're going to call the ones that we are not using for emergency lighting are non-critical fixtures. And we're going to choose one of them because we don't need all that power. We don't need all that light for an emergency. We just need one of those lights to illuminate to meet code. And we're going to call that guy our critical fixture. Now I want you to notice that there's on the left here, there are 2 sources of power, our breaker panel and our inverter. Now, while power is maintained normally, it's all coming from the same place, obviously. But when power is going to be lost, this inverter is going to be on its own. So there's 2 sources of power here, essentially. And there's also 2 control devices heading to our fixtures. Now, the first one I want to talk about is our lighting control. This is just a switch. It's just a regular switch in the wall that turns all of these 3 on and off. Well, in reality, all it's doing is turning the 2 off, because what's really happening here is, if you see our red line, this ALCR is powering our critical fixture. It is the switch for our critical fixture, and this switch is powering our non-critical fixtures. So the job of this ALCR is to mirror or mimic our switch. And in order to do that, it needs to have a couple of sense lines so it knows what's going on. So all this mirroring is done through this switched input, this little sense line right here. So whether this is sending a signal or not depends on whether the switch is opened or closed, or whether these guys are on or off. So due to this sense line right here, our critical fixture can match up with the regular fixtures. So when you walk in a room, you hit the switch on and all 3 lights come on, and you would never know that they're actually being controlled by different switches or from different places or powered from different places. One's from the inverter and one's from normal power. You'd never know, because this ALCR mimics this switch by closing its relay and opening its relay in accordance with the switch. and it does so really fast. So if you walked in a room and flicked the lights on, it's a very, very, very short delay that you wouldn't notice with the eye. However, the real job of this ALCR is to sense right here with this sense line whether there is normal power or not. Because if your MEP, if your panel is not supplying electricity to this switch, then your ALCR is going to know it through this sense line, and it is just going to snapshot its relay and it's going to hold it there, and it is not going to listen to this. It doesn't care about this. These guys are now off, and this guy is permanently on, and you can flick this switch as much as you want, but it's not going to affect this as per code. You cannot flip a switch and turn off your emergency light. So that's sort of a little bit about how our ALCR works. And our 1008 device is pretty much doing the same thing, but it does it in a different way. And there are different applications for how you can use these things, but to get a general understanding of it, again, we have 2 power sources, same thing. We have 3 fixtures, same thing. One of them's our critical fixture, and we have 2 control devices. So we have all the same general pieces in place. The only difference is we're using a generator here. This could be an inverter as well, but for this generator, it's going to lead to an emergency panel, which leads to our control device. In this case, again, this is our 1008 device. And the similarities continue with, you see you have 1 wire leading to the back end and 1 to the front end of this switch up here. The difference is, well, I should say first, the similarity is the sense input. So the BCELTS is going to know whether or not power is on or off, and it's going to use this sense line to transfer its switch. Now, the place where there's a difference is that this line right here is no longer just a signal line or a sense line. This line is the actual power coming off of the switch. So the difference is when the BCELTS notices a loss of power from the sense input, it is going to switch here, same thing. But if it doesn't notice anything, then this critical fixture, instead of being mirrored to its friends up here, it's going to actually be the exact same circuit. It's going to be the exact same as its friends. You can sort of follow this line that when the switch is on or off, it either heads this way or it heads this way through here, and nothing changes. When an emergency happens, this snaps down, and the actual source of power, as I mentioned earlier, the source of power is changed from this panel to this panel. Now, there are some differences between these. Namely, they use you can utilize different dimming. So you have dimming integration for the ALCR of 0 to 10, Dolly ecosystem, DSI, and PWM. For the BCELTS, it's got 2, you can utilize 2-wire, 3-wire, and PLC. Physically, the 1008 device over here is larger, whereas the ALCRs, I don't know, maybe a third, quarter, fifth the size of this. And also, this transfer switch has a lot more involved hardware inside of it, so it's about 3 times more expensive on average. So we talked about a switch, but what if you have a dimmer in the wall? Well, the short answer is you're going to need a couple wires, but everything's basically the same. You can see these purple wires basically follow where we did it when we didn't have a dimmer. It's kind of the same thing, and there's another little relay in here where it's just mirroring the exact same way that the switch functioned. You also have a second little circuit for dimming that functions the same way. During loss of power, this sense line is going to tell both it's going to tell the dimmer as well that it needs to snapshot, and this will be set. So say, these lights were set to 50% illumination during normal power. This critical fixture is going to be set to 50% as well. But when there's a loss of power, the dimming is going to be bypassed, and this fixture is going to be set permanently to 100%. Remember, we said before, in a way that you cannot switch it. In this scenario, in a way that you cannot switch it or dim it. So you can do whatever you want to the dimmer here, and our device will be stuck on at 100% power. This diagram sort of just shows the same thing, but now there's multiple branches. For every branch, you're going to need an ALCR. Say you have 2 rooms with 2, each room has its own switch, its own set of 3 lights. Then you're going to need an ALCR for each room. Just isn't a big deal. In summary, ALCR and VCE-LTS, they do similar things, but they do it differently, and they fit differently into a one-line diagram. There are trade-offs of cost and complexity for the different systems, but almost always there are several ways to achieve success with these. Lighting controls are a part of all modern building systems. ALCR and VCE-LTS devices fit within all of those architectures. Thank you, everybody.
Thank you, Tom. Great explanation. I appreciate that. We do have one question from the field. Go on ahead, Frankie.
Are UL 1008 devices only used when an emergency panel is present?
Not necessarily. They can be used in a bunch of different ways. Yeah, short answer, no. You can, I basically just gave descriptions as to like the most basic circuit you could run with these things, but those devices are used in a variety of applications. You can really place them anywhere.
Perfect. Thank you.